Hello everyone. This is my last video before the quiz. And this will be on the ideal gas law. So this one combines literally everything we have seen before into one law. So the ideal gas law is PV equals nRT, where P equals pressure, V equals volume, N equals number of moles, R equals a constant, and T equals temperature. So the different thing about the ideal gas law is that the units have to be kind of specific. So R can be a lot of different things. There's a lot of different numbers R can be. But to make it simple, we're going to say R equals 0.0821 liters times atmospheres over moles times Kelvin. So you will see that unit on the end is a little crazy, but that's to make sure everything cancels out. But to make sure everything cancels out, pressure has to be in atmospheres, volume has to be in liters, moles has to be in moles, and then temperature, as always, has to be in Kelvin. So that's just something you're going to remember when you're using the ideal gas law. And also ideal gas law, you're not going to have ones or twos in it. It's going to be, you're going to see pressure, volume, moles, and temperature all together. You're going to be looking for one of those four. So we'll do one quick example. So how many grams of CO2 do you have if the volume is 24,000 liters, the pressure is 755 mercury, and your temperature is 25 degrees Celsius? So see, in this equation, we have V, we have P, we have T, we are looking for N, and R is not going to be in here. R you add by yourself. So one thing we do notice, liters, this isn't in Kelvin, this is 289 Kelvin, and our pressure is not in atmosphere, so we need to convert our pressure. So just like all our other conversions, over 1, the conversion from mercury to pressure, or to atmospheres, is 760 equals 1. So you put that in the calculator, around 993 atmospheres. We have our Kelvin. So now, just like the other laws, you should work out the variables, work out the equation in variables first. This one's pretty easy. You're just going to divide by your constant and temperature to get N equals PV over RT. And now we're just going to plug in atmospheres times our volume over R's constant, atmospheres times liters over moles times Kelvin, and then our Kelvin. And see, this is why this unit is so crazy. These atmospheres now cancel out, the liters cancel out, Kelvins cancel out. You're left with moles, and that's how we're looking for grams, so we're on the right track. If you put that all in the calculator, you get 974.094 moles of CO2. That's not rounded correctly, obviously. Now that we're in moles, we want grams. So we're just going to do our mole conversion we've been doing basically all year, it feels like now. Remember, you need to add all the individual masses together. 44.01 grams of CO2 over 1 mole of CO2. If you do the math, that gives you, and then you're going to need to go back and look at how many sig figs you need. Since this one has 2, we use this one in the equation, so you say 3, this one has 3, we're going to go 2. That's what our least is. I don't get stuck now. Okay, back. And this gives us 43,000 grams of CO2. So that's the ideal gas law. I was doing the owls, and I noticed in one labeled partial pressure, it's the ideal gas law, but because the ideal gas law is in there because you have moles. So yeah, the ideal gas law is not too bad. Anything with moles just complicates everything way too much. So yeah, that is it. Let me know if you have any questions, want any more examples. Yeah, thank you so much.